You know, we walk through buildings every single day, and we just trust. We trust that the floor isn't going to give way, that the roof is going to stay right where it is. But that feeling of safety, it isn't an accident. It's actually built on a system of learning from all the times when things almost went horribly wrong. So today we're going to pull back the curtain on the hidden world of structural safety and look at the incredible system that turns those heart-stopping close calls into life-saving lessons.
Just try to picture this for a second. You're in a big concert hall, maybe a theater, and the entire massive ceiling just collapses. The only thing that prevented an absolute catastrophe was that it happened when the room was empty. Pure luck. And this isn't some made-up story. It's a real report from 2005. It's what's known as a near miss, and it's a chilling, chilling warning shot. And that incident brings up the biggest question of all, right? If a total disaster is avoided just by chance, how does an entire industry make sure it doesn't have to rely on luck the next time around? How do we take that, "Phew, that was close" moment and turn it into a lesson that actually saves lives down the road?
Well, to get to the answer, we've got to first understand the problem, the literal cracks in the system that used to make learning from these mistakes so incredibly hard.
So at its core, it's all about structural safety. And that's not just a fancy term. It's the promise that a building can do more than just stand there on a perfect sunny day. It means it can handle high winds, heavy snow, and just, the wear and tear of time. It's a promise kept through smart design, solid construction, and good maintenance.
But here's the thing. For a really long time, the way we upheld that promise had a huge blind spot. It basically created an entire industry with a bad case of amnesia.
Okay, so let's rewind a bit. Back in the 70s, people knew something needed to be done. A recommendation in '71 led to the creation of the Standing Committee on Structural Safety, or SCOSS. And look, this was a big deal, a dedicated group of experts whose whole job was to watch out for safety issues, a major step forward. But as it turned out, it just wasn't enough.
So here's where SCOSS ran into trouble. It was doing good work, for sure, but the information was coming from a really small, tight-knit group of people. This meant it was almost impossible to tell if a problem was just a one-off weird situation or if it was the tip of a giant iceberg, a widespread issue that was a ticking time bomb across hundreds of buildings.
And that gets to the absolute heart of the problem. If you don't have a way to remember your mistakes and share those memories, you're doomed to repeat them. An engineer in one city would learn a hard lesson, but that knowledge just died with them. The same mistake could be made again and again and again. So, to break that dangerous cycle, the industry needed something new. It needed a kind of confidential lifeline, a way to create a shared memory that everyone could learn from.
And that solution was CROSS, Confidential Reporting on Structural Safety. The idea behind it was simple, but honestly, it was revolutionary. It asked, what if any engineer, any architect, any construction worker out there could report a problem they saw and do it without any fear of being blamed or sued? What if we could tap into the knowledge of thousands of people on the ground instead of just a handful of experts?
And the way it works is just brilliant. An engineer sees something that doesn't feel right on a job site. They go home and submit a totally confidential report. Now here's the key part. That report is completely anonymized. All the names, the project details, the locations, gone. Experts then look at the anonymous data for patterns, and then, bam, the lesson is shared with the entire industry.
The impact of this is just massive. Suddenly, you have this incredible library of safety know-how that never existed before. That leads to better designs, fewer accidents, and it even saves money because you're catching problems before they become disasters. And because it's confidential, the people who actually see these things are way more likely to speak up.
Okay, so that's the theory. But let's get into some real-world examples from the very first CROSS report to see just how powerful this is. First up, a scenario that's pure nightmare fuel. You're in a football stadium packed with thousands of fans, and the whole grandstand starts to shake. So a report came in about a stadium stand that was vibrating a lot whenever the fans started jumping in unison. Now, the stand didn't collapse, thank goodness, but the risk of panic or a stampede or worse was very real. And the big lesson here wasn't just fix that one stadium. It was a huge red flag that engineers across the country might not know enough about structural dynamics. One report uncovered a potential nationwide blind spot. That's the power of CROSS.
All right, this next one is a little spooky. It's about a hidden danger that wasn't in the concrete or the steel, but lurking inside the software that designers use every single day.
An engineer running some calculations realized that a popular piece of design software had a bug. It just
wasn't accounting for certain forces on its own. Now, a less experienced designer might have just trusted the software and, without even knowing it, designed a weak building. The lesson here is so important. The human is always responsible. Software is just a tool. You can't blindly trust its output. You have to check the work.
And for our last case, we have a total building collapse that was caused by something so simple you probably see it in your own yard every autumn. Get this, a flat roof collapsed. And the cause? Clogged drains. Just leaves and gunk blocking the drainage outlets. So when it rained, the water had nowhere to go. It just pooled up, getting deeper and heavier, until the roof just couldn't take it anymore and it failed. It's such a basic thing, but a powerful reminder that sometimes the biggest dangers come from the simplest failures in maintenance.
So when you take all these stories, the vibrating stadium, the buggy software, the clogged drain, and you put them all together, what does it really tell us about building a safer future?
It tells us that safety isn't about being perfect. Nobody's perfect. It's about being humble enough to admit when things almost go wrong and creating a culture where we learn from it. By having a safe, confidential way to share these near misses, we're building a massive collective memory, a library of cautionary shales that makes every single person in the industry smarter and safer.
And that kind of leaves us with one last thought. Just look around you right now, wherever you are. The building you're in feels solid, right? It feels permanent. But its real strength isn't just in the steel and the concrete. It's in the hundreds of invisible lessons learned from past mistakes, lessons that were shared quietly from one expert to another, all to make sure the world we build around us doesn't let us down.